Hello, and welcome to the Gallery of Graph. And now, here's your host, Will.
Okay, and welcome to today's video, guys. Today we're going to be looking at linear equations. And with linear equations, of course, we are talking about the general format of y equals mx plus c. And as you can see, I've got m and c in different colors because these are the two most important values that we need to consider when drawing our linear equations. So, when it comes to a linear equation, of course, we're talking about a straight line graph, and we'll get into what they look like in a sec. But first things first, we need to know what m and c mean. So m, as we all know, is the first letter in the word gradient, right? And of course, the gradient is going to be the slope of the graph, right? How steep it is, and also potentially can flip the graph around when you have a negative gradient. We'll get into that in a sec. The next letter we have here, of course, is C, or she, you may like to pronounce it.
C, that's right.
And with she, what we have is it's known as the constant because it involves a integer, but more commonly it's actually known as the y-intercept because, as we'll get into in the drawing a graph from 2 points portion of this video, we will actually see that c is always going to be the y-intercept. All right, so without further ado, let's get into it. Okay, so now we are, of course, looking at a y equals mx plus c graph, a linear equation, if you will. And our most basic form of a linear equation is, of course, going to be this red one here, which is y equals x, right? Where the gradient would be 1 and there is no c value. Okay, so what does y equals x mean? It means that when, well, x is 2, for example, y is also 2, and it's a 1-for-1 ratio. So when x is 0, y is 0. When x is 4, you can see that y is also going to be 4 there. Great. Now, let's say we had a gradient that wasn't 1. Say it was bigger than 1. So what's a number that's bigger than 1? Well, it would be 2. And when you have a gradient that is bigger than 1, the graph gets steeper because now, if we have a looky-loo along here, well, when x is equal to 1, y is 2 times 1, which is 2. When x is 2, y equals 4. And the same goes for all the negatives, of course. If we have -2, we get -4, if I can get it to hold there. There we go. Great. So then what happens if the gradient was less than 1? Say it was like a fraction, like a half. Well, as you can see here, the graph gets less steep, right? I just want you to understand the very basics that as the gradient gets higher, you get a steeper graph, and as the gradient gets lower, approaching 0, right, less than 1, it goes down. And then, of course, what if you had a negative gradient? Well, as we can see, we're going uphill left to right, so to speak, right? We're going uphill in all of these different ones here. And when it comes to a negative gradient, well, instead of going uphill, we go downhill. So this black line here is what happens when you have a negative gradient. Okay, so yes, we understand that when we have a negative gradient, we're of course going downhill. Now I'm just going to clean this up before we add the next couple of lines on, otherwise it'll get a little bit too complicated. But what we can see, right, is that now we've got our negative gradient, the black line, everything's going downhill left to right. Yeah? But as you increase the negativity of the gradient, i.e. a negative number that's greater than 1, like -2, for example, what happens is the graph gets steeper. So if you're, I don't know, skiing or something and the hill is quite steep, that means that you have a very strong negative gradient there. And then, well, lucky last, of course, we need to go through this as well, is if you have a negative number that's less than 1, the graph is still going to go left to right. You're going downhill still, but in this case, it's a shallower hill. So to use the skiing analogy again, it's a green run as opposed to a black run. And then we have not m, the gradients, we have c.
C, that's right.
Which is the constant or y-intercept. And when it comes to c, if you have a +1, the graph is just going to shift up 1 in every case. So what does that mean? Well, it means that when x is 0, y is equal to 0 plus 1, right? Which is 1, for those not in the know. Then we have when x is 1, we have y equaling 2, because guess what? 1 plus 1 is 2. wham. And then in addition to this as well, if you had a negative, well, guess what? The graph is going to shift down because now you are minusing 1 from every x value. And if you were to change this and make, I don't know, let's make it x minus 2 here, well, you can see that the graph shifts down by 2. And that is going to be constant. That's going to be a trend that you see across all numbers. So the y-intercept, what it does to the graph, functionally speaking, is it just shifts it up or down. And now, because we understand what m and c stand for, the gradient and the y-intercept, of course.
See, that's right.
And how they affect the graph in visually speaking in terms of the slope, steepness, and also how much up and down shiftness happens, if you will. We're now going to talk a little bit further about the gradient. Specifically, how do we get the gradient if we were given something like 2 points, right? So what you've probably heard is that the gradient m is equal to rise over run, right? Now, what does that mean? Well, the rise and the run, yeah? Well, let's have a look on this beautiful diagram that I've drawn just here. So talking about the rise for a second, what does the rise mean? It means how much does the line go up in between these 2 points? Now, we can't guesstimate that, but we can definitely say that we have this point, which we can call point 1, right? And then we've got another point here, which is point 2. And this is based on the fact that our first point, point 1, is further to the left. And it has, and this is a telltale sign that you can work this out, is because the x value is smaller and or more negative if we're in the other quadrants, yeah? But just in the positive quadrant, the x1 value is going to be smaller than x2, right? So what we can do is to work out the rise, right, the difference in height between the 2 points, we can simply take the distance of these 2 points. So the first point is going to be y1, whatever y1 is. Say it was 20, could be 5, could be 1 gazillion. So y1, point 1 is going to be whatever y1 is above the x-axis. And point 2 is going to be whatever y2 is above the x-axis. Now, this is not very useful information, but remember, rise is the difference. And what does difference mean mathematically? It means minusing, right? So if we wanted to work out the rise, which would be this purple line here, right? Basically the difference in the height, well, all we would need to do is calculate the difference between the 2 points, which would be y2 minus y1. And similarly, with the x values, the run, which is how far along are we going in between our 2 points, well, that can be represented, of course, by x1 and x2, and then by finding the difference between them. So, of course, x1 and x2 are going to be however far they are away from the y-axis in any direction. And the difference between the two will, of course, be what we need to find in order to get the run there. And the difference, represented by this red line here, is going to be x2 minus x1. That is the equation for the gradient. So what I highly recommend for you to do as a responsible student is to write out your new favorite equation, which is going to be m equals y2 minus y1 over x2 minus x1. Now write that now. I would pause the video at this point and write it out 10 times whilst saying it out loud. Because when it comes to memorizing something, repetition is what makes you remember stuff. So the science of learning is basically repetition in most aspects of life. So yeah, write this out 10 times while saying it out loud. And I'll pause the video now.
What are you waiting for? Do it!
You guys, it's Meg's birthday next week.
Oh my god, it is! Peter, we gotta put together a party!
Aw, man, I hate kids' birthday parties. This is gonna suck more than that time I was stuck behind Will's tutoring at the airport.
May I have your name, please?
Will's tutoring.
Can you spell that for me?
Certainly, that's Will's tutoring. W as in Will's tutoring. I as in I got my free trial when I signed up for Will's tutoring. L as in look at my grades after Will's tutoring. L again as in look, Mom, I understand my homework now. S as in send Will's tutoring a message and organize your free trial session today. Space. T as in Tim, look over there, it's Will's tutoring.
So now that we have an understanding about how the gradient works, the other sort of main dealio we need to understand is the intercepts. Right? And what does interception mean? What does if you intercept traffic or whatever you're crossing over. Right? And when it comes to linear equations, well, there's going to be probably most of the time 2 points at which the equation or the graph will intercept the axes. And so, of course, we have the y-intercept and we also have the x-intercept. And that is where the line crosses the y-axis for the y-intercept and the x-axis for the x-intercept. So how do we go about finding the intercepts? Well, first we need to just go through a little bit of theory. So talking about the y-intercept first, right? What C is, which is how we get there. But this is why C is always going to be the y-intercept. So when it comes to finding the y-intercept or the x-intercept, what we have to understand how the Cartesian plane actually works. Okay, so say we're here, we're going further along the x-axis in the positive direction to the right. What happens to the numbers? They go 1, 2, 3, don't they? And then on the other side, they go -1, -2, -3. Now, of course, the Cartesian plane, right, the two axes, is just it's just two number lines that are at right angles to one another. And so for this side of the y-axis, right, the x values are all positive, aren't they? And for the left side of the y-axis, all the x values are negative. And what's in between negative and positive values on a number line? Well, it's 0. And so that means that when it comes to our y-axis, anywhere on the y-axis will be 0 or x. So if we had the point here, that would be 0, 1. The point up here would be 0, 3. The point all the way down here would be 0, -3. And so at the y-intercept, this is the statement that we're going to memorize. At the y-intercept, x equals 0 every single time. And then same thing for the y-axis. Well, as we go up the y-axis, the numbers go 1, 2, 3, don't they? And as we go down, it goes -1, -2, -3. So above the x-axis is positive for y, and below the x-axis is negative for y. And so therefore, in between positive and negative, remember our number line, is 0. And so every x-intercept has a 0 value for y. So this point here would be -3, 0, and this point here would be 2, 0. So that is what we have to understand. So essentially, at the x and y intercepts, the opposite value will be 0. So let's go through it. At the x-int, or x-intercept for short, semicolon, y equals 0. And then at the y-int, guess what x equals? It also equals 0. And so that is going to help us when it comes to doing some questions, which we will now go into.
Bart, I don't want to alarm you, but Will's Tutoring is offering an incredible deal where you get a free trial session and 3 free cancellations per term for sickness and family emergencies.
Okie dokie. So when it comes to linear equations, there's going to be two main types of questions that you're going to need. So two main types of skills that you're going to need. There are some others, but at the moment we're just looking at the very basics of the equation. And these are, of course, going to be sketching a graph or the equation. And in this case, we have the example of y equals 2x minus 4. Now, to sketch a line, what you're going to need is 2 points, right? Because you can't really do one off 1 point unless you use a different methodology, which is a little bit more complex. We're not going to get into that today. But very basics, of course. We have y equals 2x. And so what we need to do is we need to find 2 points. And what did we just learn before? The easiest 2 points to find are going to be the x and y intercept, right? And the reason we know that is because the other coordinate will always equal 0. So for example, let's do the x-intercept first. What does y equal at the x-intercept? It equals 0. And so therefore we can say 0 equals 2x minus 4. And if you've seen my algebra video, you will understand that we have 2x minus 4. The first thing we need to get rid of is going to be that minus 4. And how do you get rid of a minus 4? You plus 4 to both sides. And so that means that 4 is going to be equal to 2x. And then we've got 4 equals 2x. And of course, all the cool kids know that 2x means 2 times x. And the opposite of a times is a divide. So what we're going to do is we're going to divide by 2 now. And then that is going to give us, well, 4 divided by 2 means that x equals 4 divided by 2 is 2. Or if we were to write this in coordinate form, and I recommend that you do always try and write points in coordinate form because it gives you more information than just whatever the value you're trying to find is. So it's going to be 2. And remember, what does y equal at the x-intercept every single time? It is 0. Great, so we have 2 or 2, 0 in coordinate form. Okay, so we've done the x-int. Now we've got to go ahead and do the y-intercept as well. And so y-int, and this is also going to be yc is always the y-intercept, right? So we have y-intercept. What does x equal at the y-intercept every single time? It's 0. And so what is that going to mean? It means that we're going to get y is equal to 2 times 0, using brackets to signify substitution there, minus 4. And, right, remember, we were to just put a little template up here, mx plus c, right? Of course, 2 is going to be our gradient here, and c is going to be the y-intercept, isn't it? And if you have, well, if you have a situation where you're trying to find the y-intercept, x is always going to be 0, so the mx part of the graph is just going to be 0. So then this would become y equals 2 times 0 is 0, minus 4, which means y equals minus 4. And so once you sort of understand this concept, we can just sort of go straight to stating whatever c is for the y-intercept there. You don't have to do this process necessarily because it's always going to result in whatever the c value is there, except minus 4. And so, of course, we need to report this in coordinate form as well. So we're going to go y equals -4, or in that coordinate form, it's going to be 0, -4, because, of course, our x value is going to be 0, the y-intercept. Okay, so now that we have that information, we can go ahead and graph it. So,
hey guys, just going to interrupt the video for a second, but if you are enjoying it, then please consider supporting the channel. Old Willie's maths and memes don't put themselves together, I can tell you that. So if you would want to support my work, then please consider buying me a coffee or donating on PayPal. Additionally, I do have a Patreon where I'm going to be uploading chapter-specific solutions to the problems out of a popular textbook series that rhymes with Lanebridge, if you're in Australia. And so if you want to get that, sign up for the Patreon. And finally, if you would like more bang for your buck, then why not hire The Real Deal by contacting me on Facebook or Instagram or X or YouTube or all of the social medias and organizing a free trial session from Will's Tutoring, where you can also get 3 free cancellations per term for sickness and family emergencies. Anyway, like and subscribe to the video. That's the end of the plug. Bye!
what we're going to do is we're just going to put down a set of axes here. And for the sake of time, these axes are not going to be to scale because when you're only putting 2 coordinates on a graph, it doesn't necessarily need to be to scale.
It doesn't matter!
So we have our 2 points, which are 2, 0 and 0, -4. 2, 0, which is going to be, let's say here, right? It's going to be 2, 0. And so we can put in our little coordinate label. It's good to put in the coordinate label if you are, you know, in the lower year levels. Maybe when you start getting to the final year levels of school, we don't need to do this as much because it's sort of implied and the teacher knows what's going on. But when you're being tested directly on this stuff, say years 9, years 7 through 10, or the first 4 years of high school if you're in a country other than Australia.
Australia.
Really? Because you sound Middle Eastern.
No. Similar accents. Kangaroo. Is it?
Sure.
You'll understand that it's important to put the coordinates because that's how you get the marks. Yeah, so I'm just going to plop that down there at 2, 0, and then our other point is at 0, -4. So 0, -4. Well, I will make this actually 1 to 1. I'll just extend that axis a little bit there. And with that in mind, we are now going to go to -4, which would be all the way down there. And we can put in our coordinate of 0, -4. And then we're going to grab a ruler, or if you can freehand it, go for it. But when it comes to like an exam situation, you want to get it as straight as possible because you want it to be neat and legible for the teacher or marker to read. And so we're going to then draw our super straight line through those 2 points. And for the final thing that we've got to do, we've always got to state our equation as well and put it somewhere close to the line. And the original equation was y equals 2x plus 4. Y equals 2x minus 4. I said plus before, but of course I meant minus. So that is how you sketch a graph based on an equation.
Mom, Dad, Bart's dead! That's right.
Dead serious about getting a free trial session from Will's Tutoring. Okay, and then the second type of question you're going to get most of the time is going to be finding the equation that goes through the points. And then for an example, I've got the points 1, 6, and -3, -2. Okay, so we've got to find the equation. What type of equation are we trying to find? It is going to be a linear equation. And so what I recommend we always do is we write out our formula first. In our linear equations, we have y equals mx plus c, don't we? Y equals mx plus c. And first thing we need to look for, of course, is going to be the gradient, right? M. And what is our favorite formula in the world, which of course we all wrote down and said out loud 10 times as per the recommendation. Do it! M is equal to y2 minus y1 over x2 minus x1. And so now we need to actually figure out which point is point 1 and which point is point 2. And the way that we do that is we ask ourselves which one is further to the left or has the smaller x value. And when it comes to this particular question, well, -3 is further to the left on a graph. Yeah, so our first point here would be x1, y1, right? -3, -2 is going to be x1 and y1 respectively. And then that means that 1, 6 would be our second point, x2, y2. Right, so subbing that in now, we are going to get, well, we would get 6. And in this case, we have minus, right? And it would be -2. And then we also have 1 minus -3. Okay, and for those in the know, what happens when you minus a minus? You get a plus, of course. And so this then becomes 6 plus 2 over 1 plus 3. 6 plus 2, last time I checked, is going to be 8. And 1 plus 3 is 4. And then we have 8 over 4, 8 divided by 4. How many 4s go into 8? Well, we can do our 4 times tables. 4, 8, twice. And so the answer is going to be 2. Great. So now we know that our equation is not y equals mx plus c, it's y equals 2x plus c. How do we find c when we don't have an intercept or an equation to go off? Well, that's a good question. Well, what we do is we sub in a point. Sub in a point! Exclamation mark. And which point do we want to sub in? I'm going to say let's sub in 1, 6. Right, so 1, 6, that means that y is going to be 6 in this case. And 1 is the x, so it would be 2 times 1 plus c. And then, very hard question to begin with, we have 2 times 1. Oh, I think that might be 2 plus c. And then, well, now we have 2 plus c, and that, of course, is going to be the same as c plus 2 for those who don't know. And how do we get rid of a plus 2? Well, of course, we minus 2 from both sides of the equation, which means that we get c equals 6 minus 2, which is 4. And so, therefore, that's what those 3 dots mean. Good little shorthand in mathematical terms. So y is going to be equal to 2x plus 4 there. And then that is how the cookie crumbles. So I hope this has helped you with your understanding of linear equations. And if you did find this video helpful in any way, please hit that like button and absolutely eviscerate the subscribe button so that you can grab more of my videos. Anyway, that's it for this video. Bye!